Welcome to another edition of the Quality and Practice Minute. In this edition of the Quality and Practice Minute, I'll be discussing a CI tool. When I talk about tools, I call these segments tool talks. In this tool talk, we will discuss measurement systems analysis, commonly known as Gage R&R. Gage R&R is critical to the measure phase and the control phase of DMAIC. There are many aspects of gauge repeatability and reproducibility, and we'll touch on a few here. One of the major concerns early into a Six Sigma project is the reliability of the data that is used to determine root cause. It is very important that the data that is analyzed about the project problem be accurate and consistent to enable accurate analysis and good conclusions and good decisions that are drawn from this information. This is important to ensure that the improvement plan is effective at addressing the root cause and can deliver real improvement. Gage R&R also comes up again in the control phase of DMAIC to help ensure that the significant parts of the improvement plan can be accurately measured. This is another purpose for Gage R&R. Gage R&R is primarily a tool for determining if the measurement system used to evaluate the quality aspect of a product will produce reliable results. In either situation, the intent of the Gage R&R is to give an indication of the proportion of the variation that is present in our system that comes from the measurement system. At its very basic level, a measurement system must be able to distinguish between good and bad product. Understanding the ability of the measurement system to do that is the purpose of a Gage R&R study. There are several aspects to a Gage R&R study. Among the most important things to consider are reproducibility, repeatability, accuracy, precision, and bias. Let's start with reproducibility. Reproducibility is the measurement of the portion of the variation in a measurement system that comes from differences between people. Most measurement systems consist of two primary components of variation: people-induced variation, represented by reproducibility, and instrument-induced variation, called repeatability. We'll cover repeatability in a second. Reproducibility tells us about differences between the ways that people do the steps of a measurement method and how much those differences matter. Repeatability, on the other hand, as I said before, is instrument-induced variation. Repeatability is the portion of the measurement system variation that comes from the instrument itself. Repeatability is a measure of the ability of the measurement device to deliver a consistent result time after time over several measurements. Accuracy and precision can be taken together. Accuracy is a measurement of the measured result compared to a true result. Remember that our measurement system is intended to give us high confidence in the data that we use to decide on product quality or determine the root cause and improvement plans for Six Sigma. Precision is a measurement of the variation in results seen. Think of these two like bullseye targets seen in this picture. Bias is the difference between the measured result of a sample and the actual result of that same sample. Bias is the error that exists in the measurement system. In the example that we see here, we're looking at our car speedometer. If we compare the measured result of the speedometer at three speeds, say 30, 50, and 70 miles per hour, we can know that the actual speed of the car is going at that time, let's say from our GPS system in our car. We can determine the bias or error across the range of interest of the measurement system. The red arrow indicates the measured speed of the speedometer, and the yellow arrow indicates the actual speed as measured by the GPS. So we see that at 30 miles an hour, we're actually traveling at 25 miles an hour. There's a negative bias of 5 miles an hour. At 50 miles per hour, we're actually traveling at 50 miles per hour, so no bias there. At 70 miles per hour, however, we're actually traveling 85 miles per hour. This is a positive bias of 15 miles per hour. I'm certain that our local police officer would be very interested in this result. In an ideal world, bias would not exist, but since we don't live in an ideal world, we know it does, and we would like the bias to be predictable. That leads us to the next measurement characteristic, linearity. Linearity is the measure of the bias over the range of interest of the measured samples. In our example below, we see that at 30 miles an hour, there's a negative bias of 5 miles an hour, and that as we proceed up the scale of measurement, the bias increases to plus 15 at 70 miles an hour. This is not a linear response. If you look at the chart below, you will see that the actual speed is not a linear line. It's more quadratic or curved than straight. This is useful information to us. It tells us that we cannot apply a simple correction factor for bias across the range of measurement. If we were to apply a correction factor to the speed based on either end of the measurement range, results at the opposite end of that range would not be accurate. Secondly, the linearity tells us that the error grows as speed increase, and that measurement at the high speed end of the range are more suspect and risky than measurements at the low speed end of the range. Gage R&R is a very useful tool in your CI toolbox. It is also vital to ensuring that customers receive good product that meets their needs. Gage R&R studies are constructed to tell us how much confidence we can have in the measurement system and its results. Gage studies can tell us where we need to improve the measurement system. Through analysis of the statistics that come along with the study, we can determine if person variation is causing the issue or if the device itself is the source of variation. In any case, the Gage study is a very versatile tool to help identify improvement needs and improve quality. If you want to learn more about Gage R&R, you can sign up for our Green Belt or Black Belt training classes or reach out to us to set up an appointment to chat about your specific situation. You can find us at qualityandpractice.solutions, or you can email us at info@qualityandpractice.solutions. Thank you for your time. We'll see you next time on the Quality and Practice Minute.